Today we're going to learn how to solve systems of equations using inverse matrices. So if we have matrix A and we multiply it by a matrix X, we get a matrix B. Now let's say we know matrix A, we know matrix B, but we need to find matrix X. The way we do this is we multiply both sides by the inverse of A. So we've got A inverse times A times X. And on the right side, we would also have A inverse times matrix B. Notice that we're multiplying both sides of the equation on the left by A inverse. Matrix multiplication is not commutative, so we have to be careful about what side we multiply on. So here on our left side, we've got A inverse times A. Well, we already know that that gives us the identity matrix. So A inverse times A is the identity. We still have matrix X equals A inverse times B. And then the identity times X, well, that would just be equal to X. So, if we have matrix A and matrix B and need to find matrix X, we multiply B by A inverse on the left. So here's how this works. Let's say we've got X minus 2y equals 0 and 2x minus 3y equals 3. So we need to set up our A, our X, and our B. So matrix A is going to be the coefficients of X and Y. So matrix A looks like this. 1, 2, negative 3, times xy, that's what we're solving for, x and y, should be equal to 0, 3. Now the first thing that we need is the inverse of A. So A inverse, we'd start with the determinant of A. So the determinant of A is 1 times negative 3 minus negative 2 times 2. That is negative 3 plus 4, which is 1. That's very nice. So A inverse will be the reciprocal of 1 times, remember we switch these and negate these. So negative 3 here and a 1. This becomes positive 2 and this becomes negative 2. So A inverse looks like this. Now we take A inverse and multiply that by 0, 3. But remember, we've got to do this on the left side. So A inverse is over here and matrix B is up here. Okay, let's multiply those together. Negative 3 times 0 is 0, plus 2 times 3, that leaves us with 6. Negative 2 times 0 is 0, plus 1 times 3, which is 3. So that means that this must be x, and that must be y. So our solution is 6, 3. Now we can check using another method, or we can check just by substituting. We know that x minus 2y should be equal to 0. We get 6 minus 6 equals 0, so that worked out very nicely. And the other equation is 2x minus 3y should be equal to 3. So that's 2 times 6, 3. We've got 12 minus 9 is equal to 3, and what do you know? That worked out as well. Let's take a look at another example. Let's try 2x plus y equals 5, and 3x minus 2y equals 4. So, we have 2, 3, 1, negative 2, those are the coefficients of x and y, times xy should be equal to 5, 4. So this is our matrix A right here, so let's find the inverse of A. We start with the determinant. Negative 4 minus 3 is negative 7. So A inverse will be -1/7 times, we switch our 2 and our -2, and negate the 1 and the 3. So we've got 2/7, 1/7, 3/7, and -2/7. So that's A inverse. We take A inverse and multiply that by B. And here's B, 5, 4. So our solution will fit right in here. So we've got 10/7 plus 4/7 is 14/7, which is just 2. Then we've got 15/7 minus 8/7. 15 minus 8 is 7, and 7/7 is 1. So our solution is 2, 1. And you should always check, even if you don't actually write out the check. We know that x should be 2, y should be 1. So 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6. Minus 2 is equal to 4. So that does work out. The solution is 2, 1. So here is our summary. In order to solve an equation, a system of equations using inverse matrices, you first write the system as A times x equals b, where x will contain the variables you're solving for, in our case x and y. You find the inverse of A, then you multiply the inverse of A by B. And remember, that's going to look like this, where the inverse is to the left of B. And then always, always, always check your solution.